Hello friends, welcome back again. Now I would like to let you know about, I would like to have a talk about the phylogenetic trees. So what do you think is a phylogenetic tree? In this lecture, I would like to talk about what is phylogenetic trees, what is the tree construction methods, basically the distance based or the character based methods. Then I would like to give an example based upon the human evolution. Okay, so initially, what do you think about, can anyone think about what is a phylogenetic tree? So a phylogenetic tree is nothing but they are the branching diagrams that represents the history of life, that is the ancestral relationships among a set of species. Okay, so for example, so this is the Darwinian, all living organisms on the earth are descended from a common ancestor. This was a tree which was initially constructed. So the only figure from this is the only figure which is from the origin of species. Okay, so next I could actually say what is a phylogenetic tree. So what is basically a tree? I just want you all to know what is basically a tree is. Okay, I hope you all can see what is what am I trying to say. Can you see this? Yes. So what is a tree? A tree is nothing but it is a mathematical structure which represents a model of actual evolutionary history of a group of sequences or organisms. So what does this state? Here they are saying a tree is a mathematical model. What do you think if a tree is said to be as a mathematical model? So if this is a tree, okay, so tree vandita, you'll have these are the trees. So in this tree you could say this is your, what do you say, this is your internal node. These are also called as an internal nodes, but these are called as an hypothetical, these are actually hypothetical ancestors. This is a more common ancestor, this is the root, whereas these two are called as an hypothetical ancestors, and these are there, right? These are called as the leaf nodes, or these are also called as the tips. Okay, and these are called as an operational taxonomic unit, and these are called as an hypothetical taxonomic unit. Okay, so this is a, I'll repeat it again. So this is an internal node which is actually called as a root, and this is a common ancestor, and these two are the hypothetical ancestors, which is also known as an hypothetical, which are actually referred to as an hypothetical taxonomic units, and these are referred to as an operational taxonomic units. So I would like to also say that these like you have what do you think is called as a fluctuating? So if you say a speciation is a rare event, okay, a speciation is a rare event at a given node. A speciation occurs only once. So if it's like this, you have only two nodes. Okay, so if it's like, for example, this is a main common ancestor and you have two nodes over here, so this is called as a bifurcating. But if you could say it is a multifurcating, so bifurcating means only a speciation event occurs and there's only two nodes after that. Okay, so whereas when you say it is a multifurcating, from this if I get another node like this, then a speciation event is not diverged into two, it is diverged into more than two. So that is actually called as a multifurcating, and this is called as a polytomy. So this position, now we were saying that this position is called as a polytomy. So next, what do you think is this? This is a tree. So these trees are actually, you have a trees which can be based upon a divergent evolution or a convergent evolution. If it is based upon the convergent evolution, it means they occur between two separate species and they evolve differently from a common ancestor. Whereas in a convergence evolution, they occur when the species have different ancestor origins but have developed similar features. So these are the external branches that end with a tip. These are the external, these are the branches. So these are the external branches with end with a tip. Okay, so These are the internal branches that do not end with a tip. These are actually the tips, which are also known as the leaf nodes. These are the outer branches, okay? Next, I would like to say about, there are three types of actually you have two types, the rooted as well as an unrooted tree. So these I could say this is a unrooted tree, okay? So whereas when I say if it is a rooted tree, there are three types of a rooted tree. So first is a cladogram, okay? In a cladogram, this is a cladogram, okay? So in cladogram you have these things which does not represent the evolutionary distance. It does not give you the evolutionary time. You will not be able to calculate on a simple cladogram. It will just show you the simple relative order of an ancestry. So you say these two nodes are related to this, these two nodes are related to this one, this node is related to this, so these two and this one are somewhat related to this common ancestor. This one and this one is related to one common ancestor. So when you consider this one and this one, they are related to another common ancestor. These are related to this ancestor. So this is basically, you don't have any root, but this is actually a representation which shows a relative order of a common ancestry. So you have something called as an additive trees, okay? So in an additive tree, it is also a cladogram but with a defined branch length. So you can also see over here, in this form of representation of a tree is also over here, which says that these two nodes are there, right? These two nodes are seen to be having over here, and when you consider this to this one, this is here, okay? So this is this one and this is this one, okay? So this is a cladogram with the branch lengths and also known as a it is also called phylograms or metric trees. These are also called as a phylograms or metric trees. So you have something called as a dendrograms, which is an which is actually called as an ultrametric trees, okay? So this is called as an ultrametric trees. So in this dendrogram, you will have the branch lengths. So this is an additive tree. It is a very special form of an additive tree. Later I would also explain you about there are other types of trees which is actually called as a distance based method as well as a character based method. So in a distance based method, you will have two types, that is the UPGMA as well as the neighbor joining, whereas in the character based method, you will have something called as a maximum parsimony as well as a minimum likelihood method. So according to the UPGMA, those are the ultrametric trees. So these ultrametric trees means you have these tips, right? So these tips, and if you see this 3 plus 1 is over here, it will give you a 4, whereas 3 plus 1, this is actually an error over here. So this 3 plus 1 is giving you a 4. And for example, I could say this 1 and 1 are equal, and when I consider for this node, if I just consider this 1 plus 1 is 2, this is 2, and if I'm going to consider for this particular node, it is 1, 2, 3. So this has a total branch length of 3. Okay, so what I'm trying to say from here is in an ultrametric tree, the nodes, when you'll have that there's a special kind of an additive tree in which the tips of the tree are all equidistant to the root. They are saying that the tips is equidistant to the root. These are also the tips, but it means these are the internal, these are the branches. These are the external branches which does not end with a tip. These are the branches which does not end with a tip. These are the branches which end with a tip. These are also a tip. For this particular root node, this is a tip. For this node, this is a tip. For this is a tip. So when you consider for this one, you have this one over here, 1 over here. So they are equidistant, you can see. So here it's 1, 1. It is an equidistant. So suppose if I consider this one, so this is 1 plus 1. So this is 2. So you see 1 plus 1 is 2 and this 2. So these are means equidistance. So next, first I said you about the phylogenetic tree. So a phylogenetic tree is nothing but it does not have a root over there. So this is actually considered of these are the internal nodes and these are the tips, and these are the observed taxonomic unit. I said that those if you can remember, I said this to be the operational taxonomic unit, okay? This is the operational taxonomic unit. But when you consider for a phylogenetic tree, this is an observed taxonomic unit. Okay, so okay, I just want to just give you a test on this. So what do you think, are these trees identical? Do you think these trees are identical? I'll just give a minute to think for y'all. Do you think these trees are identical? Yes. Now, and I would say that these trees are identical. You all may wonder how I could say that these trees are identical. So if you see, this is 5 and 4. Okay, this is 4 and 5. When I go over here, this is again 4 and 5 are same. They have the same structure here. This is also having the same structure. When I come here, this is also having a same structure, similar structure. So when I consider, this is 2, 3, this is from one thing, this is 2 and 3, so this is 2 and 3, so 1. So it is just a different representations of a trees, that's it. Okay, so I already explained about the unrooted tree. So this is about a rooted tree. Okay, can you see this? So this is a rooted tree. I said this is the leaf node, and this is the internal node, and this is the observed taxonomic unit. So in this, when I come to a phylogenetic tree, which is a rooted one, I said this is called as an OTU. OTU is also known as an observed taxonomic unit or an operational taxonomic unit. These are the leaf nodes, these are the tips, these are the internal nodes, and these are the tips, these are the root, which is an ancestral node, with these are the branch which does not have a tip over here, which does not have a external tip. These are the internal branches, these are the external branches. Okay, so now I would like to introduce you about the methods for the tree reconstruction, that is the distance based methods as well as the character based methods. So in the distance based methods, it is nothing but an evolutionary distances are computed for all the pair of sequences which is based on the number of substitution. The tree is based on the relationships among the distances. Example, a UPGMA or a neighbor joining. So you all may wonder, this according to this definition, what does this mean? So I would explain you about what is this in a few minutes. Now I would also say that there is also something called as a character based method. So in this character based method, you have the maximum parsimony and the minimum evolution. In this, it sees each and every character, it analyzes each and every character in an amino acid sequence, and it will actually choose a tree which has only a minimum number of changes. For example, I can show you, because only by an example this UPGMA could be understood, the distance method could be understood. So when you consider this, I hope you can see this. So that was actually based upon the methods for the tree reconstruction. Okay, this was based on the methods for tree reconstruction. So can you see this? This is an UPGMA, that is an unweighted pair group method with arithmetic mean. It means that what does it do is, it will, the evolutionary distances for this, these are computed based on the pair of sequences where there is number of and it is based on the number of substitutions. The tree is based on the relationships among the distances. What does it mean is, you see these are the two sequences A and B. Okay, when I consider the two sequences, I have marked something called as a red color over here. So this is a substitution, so this is a substitution, so you have two substitutions, so that is why you have a distance of 2 over here. Okay, that's why the matrix gives you 2 over here. So based upon that, this distance matrix is actually constructed. So when you need to calculate the UPGMA matrix again and again and again, so what do you do initially? It is you will find this is the smallest distance compared to the others. A and B is the smallest distance compared to the others, right? So what you do, this A and B you take, and this 2 is actually divided by the number of sequence, what is the number of sequences A and B. These are the two sequences, so I am going to divide it by 2, which is equals to 1. So that's the reason I have 1 over here and 1 over here. Next, I'm going to calculate the distance of A comma B comma C. It means I'm going to group this. This is an I'm going to group the A and B, and I'm going to C with C, like this: A and B to C, A and B to D, A and B to E, and A and B to F. So A and B to C is nothing but distance from A to C plus the distance from B to C divided by 2. So when I see this, I would say, okay, so distance from A to C is what? From A to C is 4. Okay, so I have 4 over here plus distance from B to C is what? 4. So 4 plus 4 is 8 divided by 2 is equals to 4. So that is what I have entered over here. When I consider for this is 6, 6, 8. So the other values for C and D, for that I would take from this matrix and I would fill the matrix. Okay. So based upon this, the UPGMA is constructed for the second, third round, and then finally you get this tree. So these trees, if you see over here, these two things, like it was an ultrametric tree. I said initially that this is an ultrametric tree. So this ultrametric trees are actually defined by the satisfaction of the 3-point condition. What do you mean by the 3-point condition? It is for any 3 taxa, the 2 greatest distances are equal. Okay. So the UPGMA clustering method is very sensitive to unequal evolutionary rates. It assumes that the evolutionary rate is the same for all branches. Clustering works only if the data are ultrametric. Okay. So we said it is an ultrametric, and we said that ultrametric means it is an equidistant. So shall we check that equidistant method over here? So you have this over here as 4. You have 1, 2, 3 and 4 for this particular root. So actually UPGMA will help you to identify the root over here. So this is a root. Okay. So next I'm going to consider is this position, and I'm going to consider this root, this 1 and 1 is perfect. So when I consider, for example, which root? Okay, shall we consider this one? So this one, you have 1 for this one particular thing. This particular thing I'm going to find. So you have 1, 2, 3 and 4. So over here, for this one, I have the outer distance to be 4, right? So that is what is based upon, I initially say that it is based upon the ultrametric tree. So next we have called as a distance methods. What is in this distance method, I would like to give you what is the basic strengths and the weakness. Okay, so the basic strength would be they are computationally simple and quick, and the distance correction only implies on the mathematical model of evolution. So you have a weakness is, that is the disadvantages is, no insight about the actual evolutionary changes is given, and a UPGMA assumes a molecular clock. At longer times, distances are non-linear, so they require a connection. What do you mean by the UPGMA assumes a molecular clock? Okay, so when a UPGMA is said to be assuming a molecular clock, it means, I initially said you all that UPGMA clustering method is very sensitive to unequal evolutionary rates, which assumes that the evolutionary rate is the same for all branches, and the clustering works only if the data are ultrametric. Ultrametric distances are nothing but they are defined based upon the satisfaction of 3-point condition. So the 3-point condition is for any 3 taxa, the 2 greatest distances are equal. So next I would also say about, in the distance based method, I forgot to say about what is a neighbor joining. In this neighbor joining, at each step all the possible neighbor joins are checked and one corresponding at to a minimal total tree length is calculated by adding all the branch lengths is taken. For example, initially a star shaped is there, then you will see, okay, so this is a neighbor. Oh, okay, then this is the smallest neighbor, this is the very nearest neighbor. So I'm going to take this one and this one. I'm going to find the distance based on this to all the other things. Next I'll say, oh fine, this is very similar, so I'm going to construct for this one, and it's basically similar to the UPGMA, but for this neighbor joining, what you will do is you're going to construct a negative matrix. Can you see this? This is a negative matrix. Okay, so you're going to calculate a negative matrix like this. Then you will note the negative branch lengths. Based on the negative branch lengths, you have two branch lengths which are very small compared to the others, that is -13 and -13. You could pick this one or you could pick this one. For the convenience, I just picked this A and B and I calculated this matrix. Okay, so this A and B is represented as U over here, and from this again the steps again begin, that I first need to calculate this one, this step, this matrices need to be constructed based on this formula, then I would need to construct this matrix, and it happens continuously. That's what will happen. Next, I would like to also say about what is the character based state method, that is the maximum parsimony, right? So if I want to just give you an example of a maximum parsimony, I could say, for example, according to the maximum parsimony, if you're given A, C, A, G, T, T, A, C, T, G, T, A. Suppose this is your 4 sequences. For example, I'm just giving you 4 sequences. Okay, so when I consider these 2 sequences and these 2 sequences, so what could be the root node over here? What do you think will be the root node over here? Okay, so the root node for this one, what are the possible things? According to the maximum parsimony means it considers each and every. I hope you all can see this. Can you see this? Yeah. Yes. So if I say it considers each and every character. So this is one column, this is one column, this is another column, this is another column. Okay, so when I consider the possibilities for this position, it could be an A, it could be a C, it could be a T. So when I consider here, this could be an A, it could be an A, C, it could be an A, the root node. So I would say that the first position could be, when I compare this one and this one, it is just only one thing, so I would say it could be an A. So second one, if I going to compare, it could be a C. If I see this position T and A, it could be a T, comma A. So when I'm going to consider next few positions over here, so I would say, what is the first position? G. Second position T. Third position T, comma A. So this is a bottom up approach. Initially, when you are going to construct a root, you will go for a bottom up approach. Okay, first you're going to bottom, then you will go to a top down approach. I'll say that later. So for this one, what do you think would be the possible things? So when I say A and G, so my first position would be A, comma G. So what is my second position? C and T. So for example, C and T. For example, third one, T, A, T, A. So I would say this is T, comma A. So I would need to construct a better tree. So for that, what I would do, for this one, I would select any of the three, any from these three, I would select any one of the possibilities. So if I consider for the first position, if for example I consider A, for this position, if I'm going to consider a C, for this position, if I'm going to consider, this is just a random thing. You can also select like G, T, A. This could also be a possible thing. For example, just for an example, I'm showing that A, C, T. So now if I come here, based upon the root, what could I say consider for here? I could say A and A. So this is actually, you will select a thing which is having a less number of changes according to a maximum parsimony. So A and A, so you have a less change. So C to C you will have a less change. So T to T is over here. So that's the reason I'm going to select over T over here. If I see over here, it is A and A, so that is not actually possible. So anyway, you only can select G over here because there's only one possibility. Here if I say you have only one possibility, so I have two possibilities, T and A. When I compare to my root, I have a T. So this is only called as a top down approach. Okay, next I'm going to see for this positions how much number of the changes are there. So if I consider for this, there is no changes. For here I have this change, this is a change. Can you see this? You see my camera is getting blurred suddenly. So yes, now if I say this according to the ACT, there is no change. For here I say this position, the third position has a change, and when I see over here GTT, so there's no change. So this GT, here I have change. So how much changes I have? 1, 2, 3 and 4. So my maximum parsimony score is equals to 4. For example, if you're going to consider some other things, you would also have a higher score or a less score. So you would consider a score which is having a less maximum parsimony, and that would be the most optimal tree. Okay, so next I would like to say what is the character based method, what are its disadvantages and advantages. Okay, and this example of a character based method only is actually called as a maximum parsimony. So in a maximum parsimony, I would like to give you about what is the advantages as well as the disadvantages. So what is the advantages is it does not reduce the sequence information to a single letter. It provides information about the specific changes in the protein or the regulatory sequence. It tries to provide information on the ancestral sequence, evaluates different trees. So weakness is it is computationally expensive. It does not correct for the multiple mutations. Evolution is not necessarily parsimonious. It does not provide information on the branch lengths. Okay. So friends, I could, if you want, I can just rewind you of what we spoke today. So initially we spoke about what is. We initially spoke about what is a tree. So what is a tree, do you think? So for example, I could say that this is the root node. These are an internal node which is the root for these two things. So this is a hypothetical ancestor, this is a hypothetical ancestor, this is a common ancestor. So when I consider this to be an hypothetical ancestor, this is called as an hypothetical taxonomic unit, this is called as an operational taxonomic unit or an observed taxonomic unit. Okay, so there was an you also had something called as an unrooted tree. That was something like, it was something like, sorry for the very worst diagram. So this is something called as an unrooted tree where you don't have any roots over here. So these corresponds to the nodes and these corresponds to the nodes, the tips. Basically these are the internal nodes and these are the for example in this is the internal branches and these are the external branches which has the tips. Okay, so from these you can actually see you found the ancestral thing. So that's mainly based upon the phylogenetic trees. In a phylogenetic tree you would be able to find the evolutionary relationships. So you have tree construction methods which is called which is actually, you have distance based method and you have a character based method. In the distance based method I explained to you about what is a UPGMA, what is the neighbor joining, and also what was based upon the maximum parsimony thing. Okay, so I hope you liked the video and I hope it was helpful for you. Thank you friends, bye, catch you next time.